Hello. Today we're going to be talking about digital twins. So, what is a digital twin? A digital twin is a virtual representation of a physical object, system, or process that mirrors real-world behavior using real-time data. It uses simulation and artificial intelligence. It allows designers, engineers, and stakeholders to test, analyze, and optimize a system before making physical changes. So, what are some key characteristics of a digital twin? It's data-driven, it's integrative in real time, it's predictive and analytical, and it's connected. All right, so let's dive into those a second. Data-driven, it's using real-world data from sensors or manual input. Integrative and real time, it's updating dynamically and the physical objects, anytime the physical objects are changing. It's predictive and analytical. It simulates future scenarios and optimizes performance. It's connected. It's often integrated with Internet of Things technology or artificial intelligence and cloud computing. So what's an example of this? Smart city can be put into a digital twin so that it models updates in traffic flow, energy usage in real time. So why are digital twins important? Digital twins can enhance design, efficiency, and decision making. Digital twins bridge that gap between the physical and the digital world. It's offering data-driven insight that improves design, maintenance, and operations. Some of the key benefits of this include optimizing the designs, allowing rapid iteration and testing before real-world implementation or before making changes, right? Cost reduction reduces waste, errors, and downtime by predicting failures. So you're able to test before something is actually carried out. You're enhancing the user experience. It helps designers simulate how users interact with environments and products. And sustainability. It supports eco-friendly solutions by modeling and testing different alternatives without having to actually do them to figure out if they work or not. So how are digital twins used? Digital twins are applied across different industries from product design to city planning. Here's some key use cases. We can think about manufacturing and product design, simulating product performance before it's produced, predicting wear and tear for better durability, optimizing assembly line efficiency. Um, some examples of this might be creating like a digital twin of a tennis shoe before you actually put it through production so that you can simulate wear and tear and optimize that different materials to make sure that the shoe is having the longevity that you're going for. Architecture and smart cities, modeling an entire urban environment for better infrastructure planning and simulating traffic, energy use, and climate impact. An example of this could be Singapore's virtual twin, which enables citywide optimization. There's healthcare and medical devices, creating personalized health models for a specific patient. You can test new medical devices and prosthetics digitally. An example of this might be heart digital twins using cardiac treatment planning. Retail and packaging design. You can simulate customer interactions with different products and optimize the packaging material and shelf life. An example of this is using digital twins for packaging sustainability. You've also have education and training. So creating immersive virtual reality training for complex tasks, providing real-time feedback in digital designing simulations. An example of this is Boeing's digital twin for aircraft maintenance training. So how would one go about creating a digital twin? Well, first you want to define your purpose. What do you want to simulate or optimize, right? A couple of examples here would be a digital twin for wine bottle packaging that you could analyze material strength and environmental impact. A digital twin of a roller coaster could predict stress points on the track and adjust speed for a smoother, safer ride. A digital twin for film set could allow the director to pre-visualize different camera angles, lighting, before they even go in and shoot. And a digital twin for a stadium could predict crowd bottlenecks, helping organizers optimize exits and stage placement. A digital twin for a greenhouse could optimize irrigation, light exposure for better plant growth, and minimal water waste. Let's see. The next step is you got to gather the data, right? So you need sensors. You can use LiDAR 3D mapping, CAD models, taking historical data, or just manually inputting information. An example could be a factory twin that collects that real-time sensor data on machines' performance, and you're using that in your digital twin. You want to develop that digital model. So you want to use a 3D modeling, virtual reality, or augmented reality tools and simulation software. Common tools could include Autodesk, Unity, Unreal Engine, Revit, and there's even Siemens Digital Design uh, Digital Twin Suite. So you want to connect to the physical objects, right? So you're implementing Internet of Things sensors or manual updates for that real-time feedback. And then you have to test, analyze, and optimize. So you run different simulations and you can make refinements and validate against real-world performance. So that's how you use your digital twin. So a couple of real-world examples would be Boeing's aircraft digital twin, which they use to simulate real-time performance and predictive maintenance. It helps engineers test failures before they even happen, and it can save millions in repair costs and improve passenger safety. Siemens Smart Factory Digital Twins simulates an entire factory operation, so it reduces production costs, optimizes energy use for sustainability and efficiency. Amazon's warehouse also uses digital twin technology, models real-time logistics and robot movement to optimize shipping. It reduces delays, errors, and operational costs. Disney also has digital twins for theme parks, simulates visitor movement and ride demand, optimizes park layout or reduces wait times, and improves experiences. So why do digital twins matter for designers? There's more informed design choices. We're testing before we're committing those resources. Enhanced user experience simulation, improved accessibility and interaction. Sustainable solutions reduces waste and tests eco-friendly alternatives. And it's cross-disciplinary opportunities. So you work in industries beyond that traditional print design approach. So a couple of final takeaways I want you to think about when we're talking about digital twins. Digital twins are really transforming how we design, test, and optimize for real-world systems. They enhance decision-making, sustainability, and efficiency across different industries. And with the right tools and data, anyone can start integrating digital twins into their workflow. So this is just a little bit of information on digital twins to kind of get you started, and I hope you'll look into them further. Thanks for coming today. Bye, everybody.